So, whenever you're ready, can you explain what you built?
Yeah. So we have built a small retro gaming system, like the Game Boy or a smaller version of the Nintendo that we used to get earlier. So right now on this we have 3 games running, which we
Okay.
have coded in MicroPython. And just to show you a demo of the 3 games, the first one is very simple. It's a game of Pong. We have a paddle and a ball, and then we have to simply play the game. And you can see that we have a scoring mechanism and everything.
Mm-hmm.
And once the game is over, we can simply press the back button. We have to return to the menu.
And I hear you're generating sound effects out of that
Yeah,
buzzer.
and
Okay.
we are generating sound effects from the buzzer. The next one is Space Invaders. This is kind of the most complex game we have. So yeah, this is a recreation of the original Space Invaders game. And yeah, that is. If we hit the UFO, it's like extra points, like for hitting each of the
Okay.
other aliens, like 10 points. And then if you manage to hit the UFO, it's 100 points. So for this game, while we were once we had made it, we asked a few of our friends to play it, and we got some feedback. Like originally the lasers were there was only one laser that was allowed at a time, and some people wanted it to be increased to at least 2. So
Okay.
we made those changes, and also things like the lasers were not so visible, so we increased the size of the lasers as well. So yeah.
Very
So
nice.
here we also have a back button to kind of quit the game and then go back to the main menu, and we are doing so here. And the last game that we have is Snake. So for this one, it's a very simple one, and yeah, it works. So
Very nice.
so yeah, the food item is kind of generated randomly at some random coordinates on the screen, and yeah, if the snake bites itself, it's over, and then you can see the final score that you got. And yeah, again, to go to the main menu, we just have to press the back button. Yeah, so all of this is done using like a frame buffer in MicroPython. And so one of the major problems we faced while doing this was the flickering of the screen.
Okay.
And so we looked into it, how to solve that, and the major method for solving that was to use a frame buffer, which is basically a 2D array that is getting stored in the RAM of the Pico. And then when we are sending out the SPI commands, it's directly getting copied from the RAM to the screen.
Okay.
So instead of doing so, this process of copying from the RAM to the screen is very fast, and we cannot see it. We cannot see it visually when we are using the device. Instead of that, if we were sending commands directly to the display for writing and erasing it every time to update the screen, there was a very huge flicker. The further complication was that usually frame buffers are used for much smaller screens because the Pico has only a limited amount of RAM. So what we did to get around that problem was we reduced the original 16-bit color scheme that the display has to a 4-bit color scheme, and then we used the RAM. So with the 16-bit color scheme, a frame buffer for this display would require around 150 kilobytes.
Because that's a 320 by 240.
320 by 240 times
Okay.
2, that's
Yeah.
like around 150 kilobytes. And the Pico has around 256 KB of RAM, but then a lot of it is taken up by the MicroPython software. So we don't have 150 KB to allocate. So if we are reducing it to a 4-bit scheme for the pixels, then it's around 40 KB. So
Okay.
that is much more.
So you have 4 bits per pixel,
4 bits per pixel, yes.
which gives you enough colors
Yeah.
to implement games
Enough
like this.
colors, yeah.
Okay.
So on the menu screen, you can see like we have colored text.
Yeah.
And yeah, for selecting as well, we've added color to the text. So yeah, I think that is pretty much.
And the sound effects, is that
Yeah. So the
pulse
sound
width
effects.
modulation?
Yeah. So sound effects. This piezoelectric buzzer. It's connected to the Pico's one of the GPIO pins of the Pico, and we are doing pulse width modulation. We are setting a certain frequency and then playing a sound for a very short interval, and then changing the frequency so it feels to the user that we are playing some kind of a tone. Yeah.
Very nice.
Yeah.
Really,
So-
it looks like a really usable interface.
Yeah.
Really playable.
And the thing is that we can develop some more games on it, and like the whole cost for putting this whole system together is really not too much. And if someone wants, they can also look through the code and implement their own games.
Sure.
And yeah.
Wonderful. Thank you so much. That's really cool.